Hi, my name is Thomas Kim. In this session of video, we will learn unnamed placeholder keyword auto and the type specifier or extractor Decltype. These two keywords are introduced in C++ 11 and have been extended quite a lot in Visual C, in C++ 14 and 17. These two keywords play a central role in modern C++ programming. I will explain auto and Decltype about these two keywords in the future videos in more detail, but in this video I will explain the basics. For example, when we declare a variable like int a, for example, like initialize, this is initializer, or this is name, variable name, this is type. We can also, in modern C++ programming, we can also say like this, int and empty curly brace, like this. This means default value. This means default value of type int. It literally means 0, right? So this is modern way we initialize variables like this. Then when we do arithmetic with variables like a plus, for example, 1, for example, we can introduce another variable like b. Its type can be int, of course. Then in modern C++ programming, instead of specifying type like this, we introduce keyword auto. Then in this case, we introduced keyword auto and introduced b, new variable based on type of a plus 1. This is an expression. The type of this expression becomes this. Because a is integer, type integer, b actually becomes type of b actually becomes integer. This is the way we use auto. We don't need once we introduce variable name like this, then next time in all subsequent code we can use keyword auto to deduce the type of this expression. We can use keyword auto. Okay, so if we want to know the type of b, if we extract type extractor DECL type, this is the keyword. DECL type, this is keyword. If we want to extract the type of b, for example, we can say like this. DE, for example, DECL type, then parenthesis b. This means the type of b, the type of variable b. And we can introduce new variable c, for example, a times a. We can introduce like this. In this case, a is still 0, so we would say b times b, like this. This effectively means type of b. The type of b. It means the type of b. In this case, this is auto. This is b. This effectively means auto. C B times B. It effectively means this. Also, it can be int. But sometimes we should use auto, right? Most of the time, auto is this syntax. This syntax is easier to code, but sometimes we need this kind of expressions. So sometimes we need this construct. Sometimes we need this construct. They are similar, but they are a little bit different. When we declare variable using keyword auto, we always have to specify initializer. For example, int a, then I say int initialize with 0. If we want to introduce or declare a new variable, for example b, if this is wrong, if we do not specify, do not initialize b, then the type of b cannot be deduced. To make it able to be deduced, we have to initialize like this, for example. In this case, number one is by default integer of type int. The type of b will be int, integer. Or we can specify like a plus like 2, like we can put expressions like this. Then the type of b is deduced from this expression, right hand side expression. So when we are using keyword auto, we always have to initialize. This is initializer. We always have to specify initializer like this. But when we use DECL type, and we want to introduce, this means the type of A, then we can introduce a new variable named C. In this case, because we already know this part is type of A, so it is actually int. We don't need to specify. We don't need to initialize. So this is one of the biggest difference. In case of keyword auto, we have to initialize when we declare a new variable or new name. In case of DECL type, when we are using this keyword, we don't need to initialize because this type can be deduced. So this is one of the biggest difference. There are also very important difference as well, but more about the DECL type, I will talk in future videos. We'll learn more about auto and DECL type in next video, but in this video I will show you how to use them in modern C++. Okay, I will create a simple code called summation int sum int a int b. These are called function parameter. Say parameter. These are called function parameter. Okay. Say then I make a function, simple function, like I introduce int as int. I initialize with the default value. I declare the variable as and initialize with the default value of int. Then we are doing for loop int a first value a I less than b then plus I, like this. Then here we add up S I, like this. Now we return. I will make it smaller. Return S, like this, close. Now here I will translate it into auto using keyword auto. Then we can do like this. Instead of type int, I will change into auto, like this. Auto sum, auto A, auto B, then here int A, so we can say A auto S here. Then we have problem. How do we know type of the, how do we not, or can we do this auto? No, we can't do this. We have to figure it out. It's type. A's type. Okay? Say DECL type. Then parenthesis A. It gives the type of A. This statement gives the type of A. So then we can initialize like this. Default value. And the next, in the for instead of int we say auto. Auto I equals A, I less than B plus I, then S here you can say I, like this. Then we return S. This is using keyword auto in modern way, modern C++ way. Currently, as of today, I mean April 2nd of 2018, Visual C++ does not support this feature. In case of Visual C++, you still have to use int, like this. Like this. But in case of GNU C++, C++ 17, it supports auto keyword in function. So this is actually the same. This is modern way. If I translate it into template function, this is ordinary function, ordinary function. This is using keyword auto. We use keyword auto. Now I will create template function. So if we translate, we do like this, template. Here, type name. Type name is actually keyword. Template is also keyword. We say a T. I will say just a T. This template had template clause. This is called template clause. Template clause. This part is called template clause. Then return value will be T. Return value type T. Then function name sum. Like this. Then auto A means T1, TA. Auto B means t b like this. Then open curly brace, auto t s equals, and this means t curly brace, this is initializer, default value initializer. Then for t I equals a, t less than b, plus I, s plus I, return s. So this is template function. This is template function. This is using keyword auto. Sometimes you need to program like this. Sometimes you need to program like this. In case of template, if you are using template function, you are actually specifying type t, template type. This is called template type parameter. Template type parameter. Type template parameter. It is called type template parameter. In future videos, we will learn about how to use these functions, and how to use. We eventually learn that famous this is our aim of this session of video, spinning. We will learn about the spinning in the future, and I will explain, all my explanation will target toward spinning. Spinning means substitution failure is not an error. So my aim of this video is learning modern C++ programming language, but spinning is a central concept, central theme. Central theme of modern C++ programming. Spinning is very important. So this is the concept we will learn this video, and now I will move to my desktop and we will try this in C++ code. To follow with me this coding session, you have to watch my previous video, how to install GNU C++ 7.3. See, I will put the link in the comment section. If you haven't watched this video yet, please watch it. Please watch it. I start Visual Studio Code. I will create an empty folder. If you cannot see this sidebar, then press Ctrl B, then you can open it. Here I will create a folder, new folder, O1 auto, and I will say auto Decl type. Then here select this, click plus auto cpp like this. Then we are creating a file here, include IO stream int main. Then here we are creating function int sum, int a, int b, int a, int. We are declaring variable s and initializing it for int I, a, b, I, return s. Then we say Here we are calling this function sum. Please note that the last value 11 is this range from 1 to 11. 11 is not included here, so we are effectively computing from 1 to 10. So we are compiling it, save it, Ctrl S, save it, start with your command line, move to O1, auto, DECL type. Here you have to see auto CPP, Z++, and std, C++17, O, A, EXE, auto, CPP. We made some mistake here. Sorry, it should be like this. Okay, A, EXE. Oh, something happened. Let's see what happened. A. Sorry, I made type mistake here. I have to fix like this. And okay, I build again. Okay, run it. Now it works. Now, okay. Now I will compile it using Visual C++ compiler, EHSC, std, C++17, FE, colon, A, EXE, auto, CPP. Okay, it compiled successfully. Now, here, we are creating one more file here. Select this one again. Then I will say Decltype CPP. Okay. Now we are creating exactly the same program, but we are using auto and Decltype. Sorry. Drag and drop like this. You can see side by side. Here, include IO stream. Now here I will change int to auto. Auto, sum, auto, A, auto, B. Like this. Auto, S. Now we have to find out int. How do we do that? We can do like the DECL type A. It gives type of A, then we can initialize like this. So for auto I equals A, and the remaining is the same. I return S. Now we are creating main function int main. Here I will type std cout sum from 1 to 10. I say sum 1, 11. Okay. Now we save it. Ctrl S. Now we are compiling it. This is not auto. I will say DEXE, DECL type CPP. We are using Intel compiler. This is Intel compiler. We will try GNU compiler again. GCC. This is GNU compiler. DEXE, DECL type CPP. We are compiling using GNU compiler. Then it is succeeded. The build is succeed. So we type D. It works properly. A. This is previous this file. Now D works. Now we change it to compiler to Microsoft Visual C+ compiler. It doesn't work because a parameter cannot have a type that contains auto. In case of Intel, Microsoft, it cannot. Well, it doesn't work. We have to do like this. In case of Visual C++, still does not support this feature. We save it, Ctrl S, then compile again. Okay, it works now. Now we add another file, Ctrl V, to display sidebar here. I add one more file. I will say TMPL, I would just say TMPL CPP. Now I'm creating the same function using template. So here include IO stream template type name T. Here T sum T A T B. Here T S T. We are initializing like this. Then the rest is the same. I will just copy code this section and save it, Ctrl S here. Okay, I use this command T. Okay, it works. Now I will make a changes here. Here this file DECL type exe, this file I change O, and also here I change like this. We will test both files. This file works, but this doesn't work. First we are testing this one, this file. See, it has error. Now we are trying this code. This code still works, but this file doesn't. No, not this one, this file. Because this is integer type, this is double type, floating point type. So to make it work, I have to change it here. I introduce T2, then I say T2, and A and B can be all different type. I fixed like this and save it. Now try it again. Now it works. So in case of auto, it can be type of A and type of B can be different. This auto and this auto are independent. In case of if we are using T in case of T, the same like this, then type of A and type of B are exactly the same. To make them different, we have to introduce another type name like this. I hope you enjoyed this video, and in my next session, I will describe more details about DECL type and auto. Also, I will talk about the template in more depth, in depth in next video. Please subscribe my YouTube channel, and if you like, give like button. Thank you for watching.